All right, so we got some questions to run through to review on our angle basics quiz or unit circle quiz, whatever. The first one here is convert 130 degrees into radians. So to go from degrees to radians, you want to cancel out the degree symbol here. So your 180 needs to be on the bottom. You're going to multiply by pi over 180. All right. If you want to, you could just do 130 over 180 in your calculator, and that'll simplify that part for you. But all that happens are that you can divide by 10 and cancel out those zeros. So your answer is going to be 13 pi over 18. The next one, convert 7 pi over 8 into degrees. So we'll do 7 pi over 8. And we want to cancel out the radian part, the pi part. So it's going to have to be 180 over pi that we multiply by. Okay, so again, the pi's are going to cancel. And I'm going to do 7 times 180 over 8, but I have to simplify this. You could type that into the calculator. I know 8 and 180. I could divide those by 4. So that would give me 7 times 45 if I divided it by 4. And I believe that's all I can do. 7 times 45 is 315. And then I divide that by 2. And that's going to give me 157.5. Yep, that'll be my answer in degrees. All right, a coterminal question. This is just asking, what angle between 0 and 360 is the same as 980. So you're going to take 980 and you're going to subtract off 360 until you get in between 0 and 360. And I think I have to do that twice on this one. Yep. If I subtract off 360 once, that gives me 620. And then if I subtract off 360 again, it's going to give me 260 degrees. That'll be my answer. All right, same question, but we're going to be in radians. So take 17 pi over 6, and we're going to have to subtract off a 2 pi. So we're going to minus a 2 pi from this, which is the same as 12 pi over 6. All right, I'm just converting this 2 pi into something that has a denominator of a 6. Okay, straight across, and you're going to get 5 pi over 6, and that is our answer. If we were to subtract off another 12 pi over 6, it would take us into the negatives, and that's not what we wanted. We wanted to be between 0 and 2 pi. All right, this one is negative 12 pi over 5, and we're going to have to add on a 2 pi, which to add on 2 pi is going to be 10 pi over 5. Yep. All right, if we do it once, that's going to give us negative 2 pi over 5. We're going to have to do it one more time to bring us into the positives, and that's going to give us 8 pi over 5. That's it. And if you prefer, you could just take this number right here or that number right there. You could convert it into degrees and then work it out in degrees, using 360 instead of the 2 pi's if you'd rather. All right, next. Where is 21 pi over 4? Wow, so a couple of ways you could do this. The first way I'm going to do it is I'm just going to convert it over to degrees. Okay, if I do 21 pi over 4 times 180 over pi, those pi symbols are going to cancel out. Let me see what this becomes. So 21 times 180 divided by 4 is 945. So that's what this angle is in degrees. And I could subtract off a couple of 360s from it to bring it between 0 and 360. All right, that's going to make it 225. And that's going to be angle F, right? Or position F is where 225 would be, because E is 180. Now, another way that you could have done this is just by taking your 21 pi over 4 and rotating out 21 of those pi over 4 rotations, all right? Every pi over 4 is just 45 degrees, so you could have just counted until you got to 21 of them, all right? So it would be like, this is pi over 4, 2 pi over 4, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. All right. Each one of those little 45-degree angle rotations was pi over 4. There's other ways to do it, but that's good enough. What is the area of the triangle below? So we're supposed to use our sine area formula. 1/2 AB sine of angle C. But C has to be the included angle. So we're going to need this angle right here first. Well, if both of these are 30 degrees, because it's isosceles, this must be 120. All right, so it's going to have to be one of these two, A or B. It would be 1/2. A and B are both 12s. And then sine of the included angle, 120. There we go. Half of 12 is 6, and then 6 times 12 is 72. So our answer is going to be B. Okay, reference angle. So the reference angle for negative 100 degrees is going to be 80 degrees. So what I'm going to do is I'm going to rotate this direction 100 degrees. So there's 90. And this would be where I would terminate for 100 degrees. Now the reference angle it's the angle between where you left off and the x-axis, all right? Which, if this is 100 degrees and this is 180, that means it must be an 80-degree leftover. Okay. What is the reference angle for 300 degrees? So for 300, that's going to be about right here. And this time we would be measuring the angle upward to the x-axis. And if this is 300 and this is 360, it's going to have to be 60 degrees. That's going to be our reference angle. Right. Again, that chart for the way you find reference angles, if the angle is in the first quadrant, it's just the angle itself. Like if it was the reference angle of 40 degrees, it would be 40 degrees. If it's in the second quadrant, you do 180 minus the angle. And then if it's in the third quadrant, you do the angle minus 180. And then the last quadrant, it would be 360 minus the angle. All right, so like here, I did 360 minus 300, and that's how I got 60 degrees. For the other one, what did I do? I would have had to done negative 100 minus 180 because I was in the third quadrant here. Now this is going to give me negative 280, but I would have to add 360 back on that to bring it between 0 and 360. And if you add 360 to this negative 280, that's where the 80 degrees is going to come from. All right, what's the reference angle for 2 pi over 3? If you want to convert it into degrees, you could, but they're basically looking for this angle right here. That's what they're looking for. All right, if this is 2 pi over 3, and this is pi, that's a pi over 3 leftover. That's going to be our answer. What you do is you do pi minus 2 pi over 3. All right, it's it's this same rule right here, but, oh, sorry, it's that same rule, but we're in radians, so we use pi instead of 180. Okay, what's the reference angle for 21 pi over 23? Is it the same spot? Yeah, we're in quadrant 2 again. So it's just this leftover bit right here. Well, if this was 21 out of 23, or 21 out of 23 pi, the leftover bit to make a full pi is just going to be 2 pi over 3. Sorry, 2 pi over 23. Right, we had 21 of it. We only lacked 2 to make up the remainder, to make up the remaining 23 bit. Okay. All right, we're told here cosine is negative, so that means we must be in quadrants 2 or 3. And tangent is positive, so what quadrant is the angle in? Well, tangent is positive in quadrants 1 and 3, so we must be in quadrant 3. Yep. So cosine was negative, so it made it down to 2 or 3, and tangent was positive, so quadrant 3.